The distribution of heights of a large group of students is normal, with a mean of 158 centimetres and a standard deviation from the mean of 10 centimetres. The empirical rule says that approximately 68% of a normally distributed population lies within one standard deviation of the mean. Part 1. Using the empirical rule, find the range of heights within which 68% of this population lies. So the range is going to be x bar minus the standard deviation. So the mean minus the standard deviation, comma, x bar plus the standard deviation. So the mean plus the standard deviation. So remember, the mean was 158. We got that from the question. And the standard deviation was 10. So it's going to be 158 minus 10, comma, 158 plus 10, which gives us 148, comma, 168. Make sure you've got square brackets around it. Part 2. If a student is chosen at random from the population, find the probability that the student has a height between 148 and 168 centimetres. So from part 1, we know that 68% of the population has heights in the range of 148 to 168 centimetres. So we got that up here already. Therefore, the probability that the student has a height between 148 and 168 is 0.68. So we take 68%, we take the 68, we divide it by 100 to change it into a decimal, and we get 0.68. So probability is usually written as a fraction or a decimal, but more than likely as a decimal. So the probability that 68% of the population has heights from 148 to 168 centimetres is 0.68. Washers are produced so that their inside diameter is normally distributed with a mean of 1.25 centimetres. If 95% of the diameters are between 1.375 centimetres and 1.2625 centimetres, then what is the approximate standard deviation from the mean? So the empirical rule tells us that approximately 95% of the diameters will be in the range of 1.25 minus 2 times the standard deviation, comma, 1.25 plus 2 times the standard deviation. So the 1.25, remember, is the mean. So 95% of the diameters will be in the range of the mean, so x bar minus 2 times the standard deviation, comma, the mean plus 2 times the standard deviation. So we have 1.25 minus 2 times the standard deviation, comma, 1.25 plus 2 times the standard deviation. So what we're going to do is take the 1.25 minus 2 times the standard deviation and let it be equal to 1.2375. So we have 1.25 minus 2 times the standard deviation equals 1.2375, and then we just solve for the standard deviation. So we're going to bring the 1.25 over the equal sign, it becomes minus 1.25, and 1.2375 minus 1.25 is minus 0.0125, and then we're going to divide on both sides by minus 2. So minus 0.0125 divided by minus 2 is 0.00625 centimetres. So this is the standard deviation from the mean. Now alternatively, we could have let 1.25 plus 2 times the standard deviation equal to 1.2625 and solved for the standard deviation. Either way will work. However, if we had let 1.25 minus 2 times the standard deviation equal 1.2625, it would not have worked out, and likewise if we had let 1.25 plus 2 times the standard deviation equal 1.2375 and solve for the standard deviation, that would not have worked out either. So it's always going to be our mean minus 2 times the standard deviation equals the first value, or else the mean plus 2 times the standard deviation equals the second value, and then solve for the standard deviation.